Somewhere in a factory in Wuxi, China, engineers just did something that legacy automakers said was years away. They built an electric drive system that hits 93.8% efficiency. That number sounds small on paper, but in the world of electric motors, it is massive. For decades, the auto industry chased two different dreams. Japanese engineers pushed gasoline engines to their absolute limit. American and European brands bet everything on electric range and battery size. China quietly did both at once. And now, with this new announcement, they may have just leapfrogged everyone. This is the story of Geely's Thunder 16-in-1 electric drive system. It is the story of a company called Infomotion. And it is the story of how China stopped copying the West and started setting the rules for the next era of cars. Let's start with the basics. Every electric vehicle needs a drive system. This includes the motor, the inverter, the gearbox, and several other components. In most EVs today, these parts sit in separate housings. They are connected by long stretches of wiring. Every connection point loses a little bit of energy. Every extra centimeter of cable adds a little bit of resistance. Over time, these small losses add up to a real difference in range and performance. Geely's engineers looked at this problem differently. Instead of treating each component as its own island, they crammed 12 hardware modules and 4 software functions into a single housing. That includes the electric motor, the motor controller, the DC to DC converter, the onboard charger, and the vehicle control unit. All of it fits into one compact unit weighing just 75 kilograms. That is about 165 pounds, lighter than most adult humans. By eliminating more than 180 separate components, Geely cut weight, cut complexity, and cut energy loss all at the same time. They also shortened high voltage wiring by 30% and low voltage wiring by 15%. Every millimeter of removed is a millimeter of resistance removed, and resistance is the enemy of efficiency. The result of all this engineering is a peak efficiency of 93.8%, measured under China's CLTC testing cycle. For comparison, most Tesla drive units today operate somewhere between 90 and 92% efficiency. That might sound like a tiny gap, but in the EV world, every fraction of a percent matters enormously. Here is why. Efficiency determines how much of your battery's energy actually reaches the wheels. The rest is lost as heat, friction, or electrical resistance. A system running at 90% wastes 10% of every charge before the car even moves. A system running at 93.8% wastes less than 7%. That difference translates directly into extra kilometers of range without adding a single extra battery cell. And Geely didn't just claim this number in a lab. They proved it in the real world during a test drive around Qinghai Lake, one of China's most demanding high-altitude routes. A Geely TT equipped with this new drive system recorded an energy consumption of just 8.2 kilowatt hours per 100 kilometers. That is roughly 62 miles. This result was so impressive that it earned a Guinness World Record for the lowest energy consumption ever recorded by a mass-produced battery electric sedan on that route. Let that sink in for a second. This isn't a concept car. This isn't a prototype hidden behind closed doors. This is a system heading straight into production vehicles, starting with a Galaxy TT Sports sedan. Now, some of you might be thinking, is 93.8% really that big of a deal? Let's put it in context. Just a few months earlier, in April 2026, Geely's sister brand Lynk & Co. unveiled a similar system that hit 93.7% efficiency. That was already considered a record at the time. Geely's new Thunder system beat it by just 1/10%. In most industries, that would be a rounding error. In electric drive engineering, it is a genuine milestone because every fraction higher gets exponentially harder to achieve. Think of it like running a marathon. Getting from a 5-hour finish to a 4-hour finish is hard. Getting from a 3-hour finish to a 2-hour, 58-minute finish is a completely different level of difficulty. The closer you get to the theoretical maximum, the more brutal the final stretch becomes. That is exactly where China's engineers are operating right now. There's another piece to this story that makes it even more interesting. This isn't happening in isolation. Just months before this electric drive announcement, Geely made headlines with a completely different kind of breakthrough. Their i8 hybrid system unveiled a gasoline engine with a claimed peak thermal efficiency of 48.41%. That is being called the highest thermal efficiency ever achieved by a mass-produced combustion engine. To put that in perspective, most gasoline engines on the road today operate somewhere between 30 and 40% thermal efficiency. Nissan made headlines not long ago for reaching 42%. Geely blew past that number with an engine using a high 15.5:1 compression ratio, Miller cycle valve timing, and ultra-high pressure fuel injection. Vehicles using this system reportedly achieved fuel economy below 4 liters per 100 kilometers. One certified test run reportedly hit just 2.22 liters per 100 kilometers, which is close to 106 miles per gallon. So here is the real headline. In the same year, the same country produced both the most efficient mass-produced gasoline engine in history and one of the most efficient electric drive systems in history. That is not a coincidence. That is a deliberate, coordinated push across an entire industry. Why does this matter so much for the rest of the world? Let's talk numbers. China's electric drive exports rose 64.7% last year. Alone. That is not a typo. Chinese automakers are not just selling cars domestically anymore. They are shipping entire drive systems, entire powertrains, and entire technology platforms to manufacturers around the world. For years, the assumption in Detroit, Munich, and Tokyo was that China could scale production, but couldn't out-engineer the West. That assumption is now falling apart in real time. China's government has also been pushing this shift through policy. Starting January 2026, China implemented stricter national fuel efficiency standards for both traditional and hybrid vehicles. These new rules cut fuel consumption limits by roughly 18%. And by 2030, China wants its corporate average fuel consumption down to 3.3 liters per 100 kilometers. That would mark an almost 48% decrease from where the standard sits today. When a government sets targets like that, it forces every automaker in the country to innovate or get left behind. And that competitive pressure is exactly what produced breakthroughs like Geely's Thunder Drive and their record-breaking hybrid engine. Let's break down what actually makes the Thunder system so advanced from an engineering standpoint. First, there's the 800 volt electrical architecture. Higher voltage systems allow for faster charging and lower current, which means less energy lost as HEAT during transmission. Second, there's the power density of 11.8 kilowatts per kilogram, which is an extremely high number for a production-ready unit. Third, there's a 54-channel directional cooling system that lowers peak motor temperatures by as much as 15 degrees Celsius or 27 degrees Fahrenheit. Keeping a motor cooler means less energy wasted managing heat and better long-term reliability. Fourth, there's active lubrication for the shafts and gear assembly, which reduces friction during demanding operation. And fifth, there's the intelligent power optimization software layer, which manages how energy flows through the entire system in real-time, adjusting based on driving conditions. Individually, none of these innovations sound revolutionary, but stacked together inside a single 75-kilogram housing, they add up to something the industry has never seen before at this scale. And it's not just about efficiency for efficiency's sake. This system also delivers serious performance. In dual-motor, all-wheel drive configurations, it can produce a combined output of 570 horsepower, or 425 kilowatts. Vehicles equipped with this setup can go from 0 to 62 miles per hour in just 3.8 seconds. So this isn't a trade-off between efficiency and performance. Geely managed to push both metrics upward at the same time, which is exactly what makes competitors nervous. Let's also talk about the company behind the engineering, because InfiMotion isn't some random startup that appeared overnight. It's a dedicated electric drive subsidiary built specifically under the Geely Holding Group umbrella. Its entire purpose is to focus on propulsion technology, rather than splitting attention across an entire vehicle lineup. That kind of focused structure matters a lot in engineering. When a company builds an entire division around one narrow problem, progress tends to move faster. Every engineer, every test bench, and every research dollar goes towards solving one thing: drive efficiency. Compare that to legacy automakers, where propulsion engineering often competes internally for budget against infotainment systems, safety features, and dozens of other departments. InfiMotion's laser focus is part of why this breakthrough happened as quickly as it did. It's also worth noting how fast this entire timeline moved. Lynk & Co.'s 93.7% system was unveiled in April 2026. Geely's Thunder system, hitting 93.8%, was announced just 3 months later in July 2026. 3 months to gain even 0.1% at this level of engineering maturity is an aggressive pace. Most companies would need a full product cycle, often 2 or 3 years, to chase gains this small. China's electric vehicle sector is now operating on a development timeline that looks more like a smartphone release schedule than a traditional automotive one. That speed is backed by something else worth understanding: the sheer scale of China's domestic EV market. China now sells more electric vehicles in a single year than most other countries sell in a decade. That volume creates an enormous feedback loop. More cars on the road means more real-world data. More real-world data means faster iteration. Faster iteration means breakthroughs like this one become almost routine rather than rare industry-defining moments. There's a financial angle here too, one that often gets overlooked in these conversations. Every fraction of a percent in efficiency reduces the size of battery needed to hit a target range. Battery packs remain the single most expensive part of any EV, often accounting for 30 to 40% of total vehicle cost. If a manufacturer can shrink the battery by even 5 or 6% while keeping the same range, that savings gets passed straight down the supply chain and eventually to the price tag consumers see at the dealership. This is exactly why investors and industry analysts reacted so quickly to the announcement. Efficiency gains like this aren't just bragging rights for engineers. They directly affect profit margins, pricing strategy, and how competitive a company can be in international markets where price sensitivity is high. Let's talk about what this means for everyday drivers, not just engineers and analysts. Higher drive efficiency means more range from the same battery pack. That means automakers can either extend range without shrinking the battery, which cuts weight, cuts material costs, and cuts the price of the car. Given that batteries are still the single most expensive component in any EV, even a small efficiency gain can translate into real savings passed down to consumers. It also means faster charging in practical terms. A more efficient system converts more of the incoming electricity into usable energy, rather than losing it as waste heat during the charging process itself. Over the lifetime of a vehicle, that adds up to real time saved and real money saved on electricity bills. Now let's zoom out and talk about the bigger picture, because this story isn't really about one drive system or one engine. It's about a fundamental shift in where automotive innovation is happening. For most of the 20th century, Germany, Japan, and the United States defined what a great engine looked like. Precision, reliability, and decades of refined manufacturing know-how gave these countries an edge that seemed almost impossible to close. China changed the game by refusing to play catch-up in the old way. Instead of trying to build a better gasoline engine using 1990s methods, Chinese automakers leapfrogged directly into software-driven, AI-optimized, tightly integrated systems. They treated the entire drivetrain as one connected problem to solve, rather than a collection of separate parts built by separate suppliers. This is a pattern we've seen before in other industries. Think about how China high-speed rail. In each case, they didn't just copy the leaders. They rebuilt the entire manufacturing and engineering pipeline from the ground up, optimized for scale and speed. And in each case, within a decade, they went from follower to global leader. The auto industry is now watching the same playbook unfold in real time. Analysts at Nikkei Asia have already pointed out that Chinese automakers have rapidly closed in on Japan's long-held lead in engine technology through these kinds of high-profile breakthroughs. Chery's Kunpeng Sky Optimus engine, Dongfeng's high-efficiency combustion engine, Geely's iHEV system, and now the Thunder Electric Drive are not isolated wins. They represent a coordinated industry-wide leap forward. Of course, not everyone is convinced these numbers will hold up perfectly outside of controlled testing conditions. Some engineers and analysts have raised fair questions. Real-world driving involves variables that a closed testing loop simply cannot fully capture. Temperature swings, traffic patterns, tire wear, and driver behavior all affect real efficiency numbers. The 93.8% figure was measured under China's CLTC cycle, tends to produce more favorable numbers than testing standards used in Europe or the United States. Skepticism is healthy, and it's worth watching how these numbers perform once thousands of these vehicles are on the road every day, in every kind of weather, driven by every kind of driver. But even with some reasonable discount applied for real-world conditions, this still represents a serious leap forward in engineering, not just a marketing claim. So what happens next? Expect other Chinese automakers to respond quickly. BYD, Chery, Dongfeng, and others are all racing in the same direction, each trying to out-integrate, out-optimize, and out-efficient the competition. Expect legacy automakers in Japan, Germany, and the United States to accelerate their own research timelines, because falling behind on efficiency now means falling behind on price and range within just a few years. And expect this technology to start showing up outside of China too. As Chinese electric drive exports continue climbing, more than trying to build competing versions from scratch. That is exactly how China's battery technology spread across the globe over the past several years, and drive systems could easily follow the same path. For consumers, all of this ultimately points toward the same outcome: cheaper EVs, longer range, faster charging, and more competition, which historically has always been good news for buyers. The companies that figure out how to squeeze every last fraction of a percent out of their systems are the ones who will define pricing and performance for the next decade of the auto industry. Let's also address a question a lot of viewers are probably asking right now. If electric motors have always been more efficient than gasoline engines, why does a jump from 90 to 93.8% matter so much? The answer lies in how close this number sits to the theoretical ceiling. Physics puts a hard limit on how efficient any energy conversion system can be. Electric motors were already closer to that ceiling than combustion engines ever could be, since gasoline engines lose most of their energy as heat through the exhaust and cooling system. But even electric systems lose energy through electrical resistance, magnetic losses inside the motor core, switching losses inside the inverter, and mechanical friction inside the gearbox. Squeezing out that remaining 6 or 7% of waste is far harder than it sounds because engineers are no longer chasing one big obvious inefficiency. They're chasing dozens of tiny ones scattered across the entire system, and each one requires its own specialized solution. This is also why the competition between Chinese automakers has become so intense in this specific space. When BYD, Chery, Dongfeng, Lynk & Co., and Geely are all separated by fractions of a percent, it briefly translates into media coverage, investor confidence, and consumer trust. That's part of why we've seen these announcements arrive so close together throughout 2026. It's worth remembering that records like this rarely stay unbroken for long. Lynk & Co. held the record for roughly 3 months before Geely's Thunder system took it. Based on the pace of announcements this year, it wouldn't be surprising to see another Chinese automaker push past 93.8% before the end of 2026. This isn't a finish line. It's a snapshot of a race that's still very much in progress. There's also a geopolitical layer worth mentioning briefly. As China's automotive technology becomes harder to ignore, expect trade discussions, tariffs, and export policies to keep shifting around the world. Some countries may try to slow down Chinese EV and drive system imports to protect domestic manufacturers. Others may lean into partnerships to access this technology faster. Either way, this efficiency breakthrough adds one more piece to an already complicated global conversation about who leads the future of transportation. Stepping back from all the technical details, here's the simple version of this story. China set out to build the most efficient electric drive system in the world, and by most available evidence, they succeeded, at least for now. They backed it up with a real-world test, a Guinness World Record, and a production timeline that's already moving forward. This wasn't a concept video or a flashy stage presentation. It was a working system in a working car on a real road around Qinghai Lake. Whether or not 93.8% becomes the new baseline for the entire industry, one thing is clear. The center of gravity for automotive engineering has shifted. It's no longer safe to assume that the biggest breakthroughs will come out of Munich, Detroit, or Tokyo. Increasingly, they're coming out of Wuxi, Hangzhou, and Shenzhen instead. And that shift alone is enough to make every legacy automaker on the planet a little bit nervous. Think about how different this feels compared to just 5 or 6 years ago. Back then, most Western headlines about Chinese EVs focused purely on price. The story was always about cheap cars, government subsidies, and aggressive export numbers. Nobody was talking about world record engineering. Nobody was talking about beating Tesla on drive efficiency or beating Toyota on thermal efficiency. That conversation has completely flipped in a remarkably short window of time. This also raises an uncomfortable question for legacy automakers sitting in boardrooms right now. If a company like Geely can jump from a smaller domestic player to a record-holding engineering leader within a decade, how long? Can established brands rely purely on reputation and brand loyalty? Consumers care about range, price, and performance far more than they care about which country designed the drivetrain sitting under the hood. If this kind of deep dive into automotive technology and global industry shifts interests you, make sure to like this video and subscribe for more breakdowns just like this one. It genuinely helps this channel grow, and it helps us keep making videos that dig into the details other channels skip right past. Efficiency numbers might sound boring on the surface, but when you actually understand what 93.8% really means and what it took to get there, you start to see why the entire auto industry is paying such close attention right now. This isn't just a spec sheet update, it's a signal of where the next decade of cars is headed and who's going to be building them. Thanks for watching all the way through. If you want to see more stories like this one, covering the biggest shifts happening in cars, technology, and engineering right now, subscribe and turn on notifications so you don't miss the next breakdown.